Hello friends, welcome to my YouTube channel. The title of my today's video is Beautiful Mathematical Diagrams Using Two Chemistry Packages in LaTeX. Friends, in this video we discuss two chemistry packages which can be used not only to typeset chemistry documents containing formulae and structures of chemical compounds but also to draw beautiful mathematical diagrams. First of the two chemistry packages is this one. Its name is MHChem package. This is the documentation of that package. It is freely available in the internet. You can download it. And how to write chemical equations, reactions, formulae, everything is written here. The second package that I am going to use is Chemfig package. This also gives some beautiful method for drawing the structures of organic compounds, inorganic compounds, all those complicated structures you can draw using this package. Chemfig package actually depends on TXZ package, and it is better to download this package also, this documentation also for TXZ package. Some of the options, if you know beforehand, it will be quite handy if you are using Chemfig package and MHChem package. So let us straight away go to the text file. So I close it, close all the tabs. So this is my text file. Okay. So as you can see, I have used article style. And the preamble is very simple. Just use package. Option is version equal to 4 MHChem. Then MHChem will be loaded. And then use package Chemfig. Then Chemfig package will be loaded. And I have not used any other package here. Lots of other packages are loaded automatically. TXZ is one of them. Then AMS Math is also loaded. And many other packages are loaded. So now let us straight away go to this type of chemical formulae. You see zinc sulfate, copper sulfate, all these things are written here, and you can see how it is written. Zinc sulfate. One thing you observed is that ZnSO4, everything is in the same line. No hook or underscore for suffix or superscript. This CE command given by MHChem package is smart enough to understand what is subscript and what is not. So all these compounds, okay. Sometimes if superscript contains two things. For example, this CrO2O7, then 2 minus is appearing as superscript. So here then 2 minus, a hook has to be used. But if it is a single minus sign, so here you see 4 is going down in MnO4, 4 is going down and minus is going up. So, but here neither underscore is there nor hook is there. So it will understand, this command will understand everything. By the way, this text file you can download from the link given in the description of this video, so that you can read it and understand it and use it to learn everything. Then comes these chemical reactions. These chemical reactions are written like this. Okay. It can be written, all those reactions can be written within math mode, within equation also, so that you can get a equation number. Within math mode also you can write, and without math mode also, as a text also you can write. So there is absolutely no problem. all these things, how these names are written, everything is written here. You can understand them. And side by side, you read the documentation, then you can understand many things. In this video, actually, I am going to tell you something which is not available in the documentation. One of the two things, one of the many things that we are going to discuss is that we can actually mix these two packages with one another. For example, you see here while writing this particular molecule, this CE is given by MHChem package and Chemfig is given by Chemfig package, and this MHChem package command is used within Chemfig package. So that is very much permissible. So you can use it like this. Okay. Then another beautiful thing is here is look at this particular molecule. It starts with this line MnO4 to C, and then other part of the molecule is going down like this, and oxygen O is going up like this. So these are actually angles. This double colon mark is 60-degree positive angle, and this is relative angle relative to this bond. This bond is horizontal. So this is this angle is this line is making 60-degree angle with the horizon. Okay, and then name of the compound is written like this. I have written unknown compound just example because I don't know whether in reality such a compound is there or not, because I am not a chemistry person. So this chemname command is used, and one thing, whenever you use chemname command, then it is better to reset the chemname level like this. After finishing everything, this command has to be written, chemname init and then blank curly bracket. Okay. Then if you want to rotate this molecule by, here I have rotated by 45-degree. So this line is the my baseline MnO4 to C. This is the starting line. So this line will be rotated by 45-degree. So along with it, entire molecule will be rotated. So here idea is that just before Chemfig, here I am not writing name, so Chemname is not written here. So just after Chemfig, write angle 45-degree. Now here single colon mark means absolute 45. It is not relative to any line. But this double colon means relative to the previous line. Previous line is this previous bond. Previous bond is horizontal, so this is relative to that. But this absolute is absolute to horizon. Of course, this and this will not make any difference because this is already horizontal. But this one certainly does. It is minus 60-degree relative to this angle. So this O line, this CO line is, this angle is 60-degree, not to the horizon. This angle is double bond, this angle is single bond. Okay. Okay, yeah, 60-degree is this bracket. This bracket is closed here. So this relative is again to the horizon only, and this 60-degree, yeah, this 60-degree. This 60-degree is which one? This 60-degree is to C. That means this OC. This angle is 60-degree, negative 60-degree to this CO. So that means if you extend this CO here, okay, this way, then this angle is 60-degree. So it is not to the horizon, it is to this CO line. CO line will extend like this, and then this angle will be 60-degree. So that is the relative angle, and this is absolute angle. So here you see this entire molecule is rotated like this. Okay. But interesting part is that name of the chemicals are not rotated, only the bonds are rotated. MnO4 is horizontal, here also MnO4 is horizontal. only the bonds are getting rotated. Now comes this compound, this one. Now this one, before this one is written like this. Now here comes the necessity of writing this chem in it for this particular molecule. So as I said, after writing chem name, you have to write chem name in it. You have to reset the level of chem name in it. Suppose you don't write it, let me comment it out. So put a percentage sign and compile it. Then you will see here is that all these names have gone down substantially, although they come in the same line, but this distance is quite large. What we want is that this distance should be slightly smaller. So this line should go little higher. So for that, this naming, okay. So I remove this percentage sign and compile it once again and get to my previous position, so that my original position is restored. Yeah, original position is restored. Now this naming, what it does actually, it always takes the level of this naming is always takes the larger of the self level and the previous level. So here self level is much below this level, therefore it is not taking this level. Whereas you see water and ester are in the same level, because water, even though it could have written water here, but it has taken the level of ester. Okay, but this one, it has not taken level of alcohol, because originally it is much deeper than this. But this one is deeper than water. That's why water has taken ester level. So this initialization of this chem name, if this percentage sign is removed, what I am asking it to take this level as the level for everything. Now this one will take this level unless this level is much deeper than this. Now here I can see that ester is already deeper than this carboxylic acid. So if I use this carboxylic acid here, then only these two will come to the same level, but these two will not come. Let me compile it. So you see, yeah. So you see the first two are in the same level, but these two are in the deeper level. So they are not in the same level. So what we have to do here is that we have to take this as our base level. So we have to change the base. So it is RCOR prime. So we have to use this one, chemfig from here till here. So we have to copy this one and we have to paste it somewhere here, and then we compile it. And now you see the level is all are in the same line. So you have to take the baseline as the deepest level as the baseline. Then you will get the perfect alignment. So this is one thing. So this is also done similarly. Okay, the alignment is taken like this. So and what is written here is that here this carboxylic acid, you can write it in two lines. So for that it's very easy, just use a double stroke like this. So it will go to this. Now how this diagram is written, this complicated diagram it is written, you can actually see here, you see that this particular molecule is common in every corner, every vertex this is common. So and on the left side also same molecule is there, but the design is different. So there is a defined submolecule, this type of command is there. So this curly bracket, square bracket gives the left side option, okay, on the left side of this vertical line, and this curly bracket gives right side of this vertical line, including the vertical line. So what you have to write in the, what you have to do in the right side, you have to write this command here, and on the, for the left side you have to write this command, this one, okay. These are all angles. OH is 210 degree absolute angle. O is 150 degree absolute angle. That means from this horizon to this one is 150. Then this one is 210. This angle, this horizon angle is 30 degree plus sign, and this OH is minus 30 degree. And then Camfig, this ring is given by this. All this thing you will get in the documentation of Camfig package, and then this molecule will be printed here. Now let us now go to the mathematical diagrams, which is our main interest. Look at this mathematical diagram. Okay. Now without using this package, if you want to draw this diagram, you have to do lots of calculation. Okay, I just make it slightly bigger so that you can see it actually. Okay, you see for accuracy, the arrow just from the center of this cross mark, this arrow is going down just in the middle. Everything is perfectly done. This arrow, look at this diagonal map is written diagonally. This, okay, everything is perfectly. This is coming down from the center of this arrow. Okay, everything is done perfectly. Okay, so but no calculation, no uh, assessment is required. Very simple diagram. So what you have to do is scheme. You have to write it between scheme start and this. By the way, this begin center and end center is just for centering. Even if I don't write all this thing, no problem. This begin figure and end figure I have written only to give a number of this figure and a caption for this figure. You can remove them if you don't want any caption. For example, this diagram, no caption is there. Okay. So here, and this is diffract, this is easy to understand. And now this arrow is given by arrow, then within first bracket whatever is written here, these are G, Z, G, it is just naming the source and the terminal of the arrow, the domain and the range. So GZG is the domain, name of a domain. Okay, and this is a HZH is a name of this range, so that I can use it later on. And then arrow style is this arrow style. Within curly bracket you have to write arrow style. And then there are two square brackets. One is this, another is this. First square bracket means whatever you have to write on the top of this arrow. Second square bracket means whatever you have to write below this arrow. Then these options are comma 2 means length multiple. It is twice the default length. There is a default length, so it is twice that default length. And arrow options is like this. First option is angle, second option is length, and third option is style option. It's a thick jet option, or whether thick option you want to take. Dashed arrow is, for example, here I have used dashed, so that this line is dashed. So then this one. Then similarly for 8z times this also, this for this is written arrow. Now for this arrow, only the range HH is written. That means for this one I have written HH, but HZH is already there. We have already named it, so no need to name it once again here. So that's why before this dash hyphen there is no name here. Actually this arrow is starting from this one, but this name is already given here HZH, so no need to use it. Okay, so like that. Now comes this arrow, this particular arrow. Now this particular arrow is given by this, and here you see arrow. Now this A arrow bar symbol is written here GZG, because GZG is already naming is already done, and arrow bar means we are using the already named domain, so it is starting from that domain. So arrow length will be decided by this only. Length and direction, everything, whether it should start from here or here or here, it will be decided by this. So angle, this one we will start from this. So this one you will be this arrow. Then here, if you look at it like this gamma g is written on the left side. So this star 0 means this gamma is written horizontally. If I don't write this star 0, for example, let me delete it here, then you will see this gamma g will be, yeah, it has gone like, it has become like this. Okay. So therefore, that is why this star 0 is needed. Okay. So this is starting from this only, GZG, that means it is starting from here. So it will start exactly from here only, from the middle of the molecule. Okay. And then it will go vertically downwards, so minus 90 degree. This is angle. And then 2 is twice the default length. And then this domain is, range is G prime. So we have written here, and G prime name is given GG. Similarly, this one also, this is already named. So it is GG to, okay, first we are doing the diagonal. Diagonal is from this GG from here to HZH. So that is why both are arrow bar symbol is written. Okay. And since arrow bar symbol is already in the both range and domain, no need to specify the angle. Angle will be determined by this only. Whether it is 45 degree or 40 degree or 65 degree, don't have to bother. Only thing we want is that it should be a dashed line. So I have written dashed here. And then finally this line. This line also, domain, range, everything is already defined. So we are using arrow bar symbol. So again, no need to specify angle, and length also no need to specify. It will be automatically done. Okay, psi comes below, so psi is below. Now, why I have written solid here? One thing I have observed, it is not written in the documentation, is that if you are using arrow bar symbol at both places of both side of the hyphen, then whatever style you have used on the first occasion, same style will be maintained in the second occasion. Suppose I don't write solid here, you will see that this line will be dashed. Even though I am not writing dash here, but it will still be dashed. I am compiling it once again. You see this has become dashed. So that is why we have to write solid. Okay. Similarly, here also this has been explained here, that this is a just a example I have written, and here I have used dashed line from A to C. So from A to C I have used dashed line, and these are again arrow bar symbol is there at both end. Here I have not used dashed line from D to E, but D to E is giving dashed line, you see. Then I have changed the style here. I have made it red, white, and so all kinds of things. So these three red, one I have just made A to B. So A to B. So I have made only red this one, A to B. But E to C, D to E, I did not make red, but still it is becoming red. So that means this style is maintained here. Okay, so if you want a different style here, you have to specify it clearly. Okay, just like this one. Next comes this graph. You see again this graph, for this graph also so many things are done automatically. So for bonds, there are several options. So first one is angle, second one is length multiple actually, second one is length, third is departure, that means where from this from where this bond is starting, then where it is arriving, fourth one, fifth one is tick jet options like styles, etc. Now here what you have to do, these things means atom separation. What is the distance between two atoms, two vertices here? So this is a graph I have drawn, and bond upset, how much deep it should go inside. You change these numbers and you will see what is the effect. So it is constructed, first of all this is constructed from, so this bullet is the center, then from the center it is going in, this blank means 0 degree. Now this first, in the first place option 2, 4, 6, these are actually multiples of 45 degree. So this is 0 into 45, this is 2 into 45, this is 4 into 45, this is 6 into 45, like that it goes. So first of all it goes horizontally 0, so it is connected to this, and this is named as A. Question mark A means just a name, it is not printed here, but just for the for this program to understand which vertex is what, this name is written, question mark A. Then second one is written, its name is B, but when you write question mark A also side by side, it means these two vertex are to be joined. So these two vertices will be joined. Now there is no joining directly from here. You see, this is joined with the middle one. This vertex is joined with middle one. This bond means this bullet, this first bullet, center bullet is joined with the top bullet like this. This 2 means 2 into 45 is 90 degree. So from here travel 90 degree and reach here. So that means this line is this one. But what about this line? This line is given by this A only. If you write question mark A here, that means these two will be added. Similarly this one CB, that means it is joining C. So this one is joining C, but B is also there, so CB will be added. Last one is name is D, but A is there, C is there, that means it will be joined with A, joined with C. And then comes this one. Okay, this one is joined with this below. Now there is no name for this vertex, so it is blank only. There is a bullet here, but I have not drawn any bullet here. But its name I have written chem below. Okay, 4.1. So this way. Now this is joined with what? This is joined with 6 means 6 into 45. That means 3 pi by 2. So here. Okay. Then minus 3. So this line is which line? This line is this one. So this 2. Chem below 4.2 means this number is 2. So below this molecule, chem below means below this molecule, here it is a empty molecule. Below that empty molecule, that's why this curly bracket empty is there, 2 will be written. And then this one is dashed line. So then the first dashed line is coming here. And below will be written 1. Now this one is 3 is neither below nor above. So chem above, chem below will not work for this 3. So for that one has to use a trick. So this is, we are here. So we just draw a blank bond. For drawing a blank bond is draw equal to none, but its length is 0.25. So just at a distance of 0.25 times the default length, this 3 will be printed, and between 3 and this there is a blank empty bond. Okay. That is how 3 is there. Similarly, this 3 is also written like this, empty bond. Okay. And then this 1, 2, of course, like this. So this way it is done. Then last one is, if you want this type of chart where suppose this is a you want a bond starting from D, then starting from C, starting from B, starting from A, and here also it is going to first of U, first letter, then it is going to second letter, this is going to fourth letter, this is going to 1, 2, 3, 4, 5, 6, sixth or seventh letter, sixth letter. So you see this is how it is written. Okay. 20, 30. Here I have written somewhere, first is angle, second is length, third is departure, fourth is arrival. So you see the thousand is sixth column, sixth letter. So it is written 6 here. So it is arriving at A, sixth letter. And dash pattern also, different types of dash pattern I have written. First one is dashed, simple dash. Second one is loosely dashed. Third one is densely dashed. And fourth one is manually dashed. So that means dash pattern, length of each dash is 2 point and length of each gap is also 2 point. This you can always change. So you see different types of dashes is possible, are possible. So you can use them to draw similar beautiful diagrams which not much of effort, no need to calculate how much angle you have to write. And most of the, it is once you start drawing, then after that many of these command you can just copy paste. Okay, and it is quite easy and handy, these packages, even though these two packages are for chemistry people, but we mathematicians also can use them for our documents. Hope this video will be useful for you. Thanks for watching, and don't forget to download this text file from the link given in the description of this video. Okay, thanks for watching.